He also concluded that the objects which were furthest away were travelling fastest. That's not unreasonable. If an object travels to here in the same time as an object travels to here, then this object must be travelling faster than this object because it's gone further. So the further something is away, the faster it must be travelling. Consider a piece of elastic that is 4 centimetres long. We're going to give it coordinate points 1, 2, 3 and 4, and we're going to pin it and anchor it at that point. Now let's stretch the elastic so that it's twice as long as it was before. The coordinate points have now been stretched 1, 2, 3 and 4. Let's imagine that they were 1 centimetre apart here and they're now 2 centimetres apart here. If this whole process took 1 second, what can we say about each of the coordinate points? Well, point number 1 travelled 1 centimetre from there to there. 1 centimetre in 1 second. So its speed or velocity was 1 centimetre per second. Point number 2 travelled from here to here, a distance of 2 centimetres in 1 second. So its speed was 2 centimetres per second. Point 3 travelled from here to here, that's a distance of 3 centimetres in 1 second. And point 4 travelled from here to here, that's a distance of 4 centimetres in 1 second. And so you can see that the further away the point is, the faster it's travelling. We can also see something else about that, and that is that the distance now divided by the velocity is a constant. The distance of point 4 is now 8 centimetres away from the fixed point, and its velocity was 4 centimetres per second. And so the distance divided by velocity is 2. Similarly, point 3 is now 6 centimetres away from the fixed point, and it travelled at 3 centimetres per second. So distance divided by velocity is 2. Point 2 is 4 centimetres away from the fixed point, and it travelled at 2 centimetres per second. 4 divided by 2 is 2. And finally, point 1 is 2 centimetres away from the fixed point. It travelled at 1 centimetre per second. d over v is 2. More generally, if we take a coordinate frame where we regard that as the fixed point and we simply label coordinate points 1, 2, 3, 4 and so on, and we say that the distance between neighbouring points is a, but that a can vary with time because as this expands, a will get bigger, the distance between any 2 points will get bigger. Then we can say that the distance between any particular points we choose, let's say the distance between 1 and 4, that distance will be the change in the x-coordinate, 4 minus 1, times the distance between each coordinate, times a. We can differentiate that with respect to time. dd with respect to time is delta x times dA over dt. We can write dA by dt as a dot. It's a convention. dA by dt is a dot. But dd by dt, the rate of change of distance with time, is of course just the velocity. And that equals delta x times a dot. We can multiply by a over a because that is simply multiplying by 1. But now delta x times a is d. So now we can say that v equals a dot over a times d. And a dot over a is Hubble's constant h. So v equals hd. And that's the famous Hubble's equation. Hubble could now take this equation And knowing the velocity, which of course he could calculate from the red shift, he could work out how far the galaxy was away from the Earth. What are the units of Planck's constant? Well, the unit of velocity is meters per second in SI units. And the unit of distance is, of course, meters. And that means that h must be measured in per second, or second to the -1, or 1 over second, depending on how you want to put it. But in fact, Hubble's constant is, these days, expressed in a rather peculiar way. It is currently thought to be of the order of 75 kilometers per second per megaparsec. A megaparsec is an astronomical unit. It is approximately 3.26 light years. The 75 is the latest estimate. It's actually very difficult to calculate Hubble's constant. When Hubble first did it, he got a value that was 8 to 10 times higher. If we express Hubble's constant in terms of per second, then Hubble's constant is actually approximately 3 times 10 to the -18 per second.